Good morning to all. Today I will explain the program. The program name is ADC in LPC 2148. So ADC means to convert the analog into digital form. Okay. So here we are mentioned hash include LPC 214x.h. So that means here mentioned the header file for LPC 214x functions. Okay. Hash include stdint.h. Then hash include LCD 16 by 2 dash 8-bit.h. Here we are mentioning the header file. Okay, so this header file itself we return the some program, so you can access that program. Okay, hash include stdio.h. So that means to perform the standard input output functions. Hash include string.h to perform the string operations. That means we can write the string operations. Here stdint.h means to perform the integer operation. Integer means values. Okay, numeric values. So here in main program, int main within the bracket void, open the loop, unsigned integer 32 underscore t result. So for the result itself we are mentioned the unsigned integer. So then float is the voltage character volts of 18. Okay, volt volt of 18, LCD underscore init. Okay, then pin select one. Here 0x01 00000. So that means here it perform the port 0.28 as AD 0.1. So to enable the here to enable the address and data analog to digital conversion. So and also ADC operation, it can access the address with the help of the address line. It can take the data values. Okay, so here I perform the analog to digital conversion operation AD 0.1. Then AD 0 CR is equal to 0x00200402. So here ADC operation is performing for ADC operation. Here we are using the 10 bits and also used for conversion 11 clocks for conversion. While of 1, it is the unconditional statement. Okay, so it will not terminate the loop. Continuously it will execute the program. AD0 CR equal to AD0 CR or 1 is less than 24. So that means to start the conversion, whenever the input we are taking the potentiometer. So whenever I am varying the potentiometer, it will give the some voltage. So output voltage in display the LCD output. Okay, so whenever varying the voltage, that means 1 volt came, so that time it start the conversion. Okay, so for that 1 volt we need to convert into digital form. That digital value is displayed in LCD because we are taking the output is the LCD display. Input we are taking the potentiometer. Then while of here observe the statement AD0 DR1 and 0x800000. Wait till done. So up to the end of the conversion it should be wait. So then result equal to AD0 DR1. So in this register store the result after the end of the conversion. So then result is equal to result is greater than 6. Okay, so then result is equal to result and 0x00003FF. Okay, so then voltage is equal to here within the bracket, again within the bracket, result by 1023.0 into 3.3. So that means convert the ADC voltage to equivalent voltage. That means convert the ADC value into equivalent voltage. Suppose you are taking the 1 volts. So then digital output is the 001. Okay, so whenever the equivalent voltage is came, that time it stop the operation. Suppose if we are taking 001 1 volts, if you are taking 0010, then 2 volts. So before reaching the 2 volts, it will stop the conversion. How it converts? So if you are taking the 001, so then it will check the 00110. Last bit is the 1. That means high value. Then again it compare 00. Last bit will set the 0, then 10. Again it compare. It is not equal. Again whenever 0001, that means it is equivalent to 1 value. Then 1 is equal to 1 means 1 volts to stop the operation. Okay, so LCD underscore command within the bracket 0x80. Okay, s print of volt comma within the bracket within double quotation voltage equal to percentage of 0.2f volts comma voltage. It print the voltage value, that means it print the output on LCD. Here observe this one, LCD underscore string of volt. So memory set volt comma 0 comma 18. Okay, so how it print the LCD output? For that's why here mention the LCD dash 16 by 2 dash 8 bit dot h. So that program here written separately. Okay, so whatever you created project, in that we have to create the one text document. In that you write the this header file program. You should save the file name should be .h. So save as .h. That means if you save as file name is LCD dash 16 by 2 dash 8 bit .h. So like that to save the header file. Okay, so here we written the header file void delay underscore ms. So within the bracket unsigned integer 16 underscore tj function for delay in millisecond. Okay, so here we are taking the LCD output is the 8-bit display. It is the 16 by 2 LCD. Okay, so here unsigned integer 16 underscore t x comma I. For I is equal to 0 semicolon I is less than j semicolon I plus plus. So within the loop for x equal to 0 x is less than 6000 semicolon x plus plus. So here it perform the to generate the time delay is 1 millisecond. So that is we are taking the clock frequency is the 60 megahertz. Okay, here we are mentioning the clock frequency is the 60 megahertz and also time period is the 1 millisecond. Then close the loop void LCD underscore command character command. So here command write. Okay, so here IO0 pin, then it is equal to IO0 pin and 0xFFF0FF. Command is less than 8. Okay, so IO0 set is equal to 0x00040 to enable the 1. So whenever if you are taking any chip read operation, that chip should be enabled. So if you are taking any IC, it should be have the enable pin, that should be 1. IO0 CLR is equal to 0x00030, RS equal to 0, RW equal to 0. So that means here read write operation should be 0, RS should be 0, read send. Okay, so whenever they write the data, for that time read send 0 means it send the data to LCD output, it read and write the display. Then delay underscore ms of 2. IO0 CLR is equal to 0x00040. That means CLR means to clear the enable pin. Here set means IO0 set means to enable the chip IC input. Okay, whenever n equal to 1 means to start the operation, whenever n equal to 0 to end the operation. RS and RW unchanged, that is RS equal to RW equal to 0. Delay underscore ms of 5. So close the loop again void LCD underscore init within the void LCD underscore init within the bracket void open the loop IO0 dir is equal to 0x0000FFF0. So here port 0.8 to port 0.15 is used for the LCD data. Port 0.4 5 6 as RS, RW and EN. Okay, for LCD we should use these 3 pins also, RS, RW, EN. For data itself, here we are using the 8-bit data, that's why we are taking the port 0.8 to port 0.15. So then delay underscore ms within the bracket 20. Okay, delay underscore ms within the bracket 20. Then LCD underscore command 0x38 initialize the LCD underscore command 0x0c display on cursor off. LCD underscore command 0x06 auto increment cursor. That means whenever it print the 1 volts, if we are taking the 20 volts, to print the 20 volts means the cursor should be increment, 1 printed then 2 printed, 12 volts like that. So LCD underscore command 0x01 display clear. LCD underscore command 0x80 first line first position. Close the loop, then void LCD underscore character within the bracket character MSG. So we open the loop. Here IO0 pin is equal to IO0 pin and 0xFF00FF and or MSG is less than 8. So that means received message should be 8-bit data. So it compared the that 8-bit data is less than 8. Whenever it will stop the 9-bit data. Only it will receive the only 8-bit data. Then IO0 set is equal to 0x000050. So that means to enable the RS1 read and send operation, comma, and also enable the chip operation en equal to 1. So then IO0 CLR is equal to 0x00020. Rewrite is equal to 0. Then delay underscore ms within the bracket 2 semicolon. IO0 CLR is equal to 0x00040. That means enable the is equal to 0. RS and RW is unchanged. So that means RS equal to 1, RW equal to 0. So then delay underscore ms within the bracket 5. Close the loop. That means here to rewrite operation is performed whenever 8-bit data is received that time to enable the IC operation. So that time here observe the main program. What it do? Whenever 8-bit data is received, then it internally it perform the successive approximation ADC operation to receive the analog data and convert into digital form. Okay, so here the 8-bit data is received. That means if we are received 1 volts, it compare that 1 volts whenever it is equal to start the operation and display that 1 volts. Okay, that means internally it taken to convert it analog to digital form. That digital data is displayed on LCD. That 1 volts is displayed on LCD. So here observe here again we need to print the string. So again we return the some sub program in LCD 16:2 header file itself, void LCD underscore string within the bracket char star character star msg, open the loop uint unsigned integer 8 underscore t I equal to 0. That means here 8-bit data should be print, while of msg of I is not here, while of msg I is not equal to 0. So we open the loop LCD character msg of I, then I plus plus. That means to print the 8-bit data whenever it is not equal to 0. Whenever 0 came, to stop the operation and print the output on data. Okay, so in program, observe in main program. So here sprintf, whenever to stop the operation, that time volts comma within the bracket voltage is equal to percentage dot 2f volts double quotation comma voltage, then it print that voltage value. 1 volts means 1 volts. Then close the loop. Then void LCD underscore data within the bracket int 8 underscore t data. Then open the loop IO0 pin equal to IO0 pin and 0xFF00FF or data is less than 8. Then IO0 set is equal to 0x000050, RS equal to 1, EN equal to 1. So to enable the start operation, so IO0 CLR is equal to 0x00020, rewrite equal to 0. Delay underscore ms of 2. So here it generated 2 milliseconds. IO0 CLR equal to 0x00040, enabled equal to 0, RS and RW unchanged, that is RS equal to 1 and RW equal to 0. So to stop the operation, that data should be unchanged. Okay, that data should be printed on the output display on the LCD. Delay underscore ms within the bracket 5 semicolon, close the loop. Okay, so like that here the LCD header file whenever the ADC operation is performed, that time it should receive the data. That data is printed on the LCD display. Okay, so in main program here to print the data, that means so how it print, with the help of the LCD display it take the data and display the data. That's why you return the header file for LCD display. So here we written the program ADC. So how it conversion? Okay, I will explain here in separate block diagram how it performing the internal operation. So whenever clock it receive the clock signal, so clock signal means low to high. Okay, so high to low, like that. Here successive approximation register is there. So then here the input is given V reference voltage, then V in voltage. So here initially V reference is the 0 volts. So here V in is the, suppose the potentiometer is measured to 1 volts. The 1 volts is given to sample and hold circuit. It will hold that value until it receive the next value. Okay. Suppose 1 volts to 1.5 volts. That means we are varying the potentiometer value. Then 1 volts is came. 1 volts operation is done. Then output is displayed on LCD, that digital data. Okay, the digital data it displayed is 1 volts means 1 volts. Okay, so that means the 001 binary data and converts into 1, then output is displayed 1 volts. So like that, here it received the 1 volt sample and hold circuit. It take the sample and hold that data and hold that sample. Okay, so whenever it given to 1 volts to comparator, so V reference is the 0 volts. So initially here the successive approximation register will set the all data bits. If we are taking the 8-bit data, that means D0 to D7 bits are all 0. Then output is given, digital to DAC will give an output is the, here it converted digital to analog conversion. The analog output is the 0 volts. Compare the here two values, 1 volts and 0 volts. So it is not equal. Then it go to again successive approximation register. So then what it do, here it will set the least significant bit MSB, LSB. So here MSB, here LSB bit D0 is the 1. So that time here output is the converted 00001. Output is converted 1. Again comparator is the DAC output is given to the input of the comparator. Again it compare the 1 volts. So then it equal. Okay. So then it go to again the output is given to the successive approximation register. So here again it is set the D1 bit 000010. Here 0000011. Okay, next bit will set. Then what it do, here again DAC, it convert the digital to analog conversion. Okay, so the value is the, here output is given to the input of the comparator. Okay, so you can observe here that output is the 3, DAC output is the 3. Then compare 1 and 3 is not equal. Then again go to the comparator output is given to the successive approximation register input. Okay, again here D01, D1 again set the 0. So that is given to the input of the DAC. Again it convert the output. Again the output value is the 1. Again here it take the V input value is the, for sample and hold it's given 1 volts, here 1. Compare it, again it given to the comparator output is given to the input of the successive approximation register. So whenever it is equal, to stop the operation, so that is given to the DAC. Okay, here to stop the operation. Okay, that means it will not give the it will not give the any bit set or reset. That means to stop the operation means to end of the conversion. Okay, to stop the operation, that output is given to the LCD output. Okay, 1 volts is given to the LCD output. LCD here we are using the LCD 16:2 8-bit data. It receive LCD will receive the 8-bit data and display that 8-bit data display the 1 volts. Okay, so this is done internal operation. Okay. So observe the output here. After program is executed, that exa file should be dumped into in microcontroller. Okay, ARM7 microcontroller. So after dump the program, after dump the exa file, so in that we are run the kit. Okay, so input we are wearing the potentiometer and observe the output voltage on LCD and multimeter. Okay, observe in LCD and multimeter. If you are given the 1 volts, observe the output on LCD and multimeter 1 volts. If you are given the 2.33 volts, that time observe the in LCD and multimeter we can observe the output voltage 2.33 volts. So observe the output here. So here we are done ADC program using the LPC 2148. So whenever you are taken the ADC program is done, here we are taken the input is the potentiometer. Some here ports are connected to input is the potentiometer, some ports are connected to output is the LCD. Okay, so whenever hearing the input potentiometer, we can observe the output voltage. Okay, so observe here this voltage and this voltage both will match. Okay, 0.12 again observe here. Okay, 0.17 here, 0.153, so 0.16, then 0.16, 0.29, 0.277. So like that we are hearing the input voltage. So output we can observe the voltage 0.23 volts, here also 0.23 volts.